Okay, so we talked about long division of polynomials in the last video. This video we're going to look at synthetic division of polynomials. So here we have a polynomial divided by a factor, x minus 2. And so to do synthetic division, we write down the coefficient for each of the terms. Now if a term is missing, we put in a 0. So for the first term, which is the 5th degree, the coefficient is 1. The 4th degree is missing, so we put in a 0. Third is -4. Second is 1. The first degree is missing, so we put in a 0, and then the constant goes on the end. Then I draw this symbol. And then we're going to divide by the root. So we're given a factor. So remember, to find the root, we set it equal to 0 and solve for x. So we're going to divide by the root, which is 2. So there's two steps. First you multiply, and then you add. So we bring down the first number. So multiplying first, so 2 times 1 is 2. 2 plus 0 is 2. 2 times 2 is 4. 4 plus -4 is 0. 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 is 2. And 2 plus 0 is 2. 2 times 2 is 4. And 4 plus -4 is 0. Now this last number here represents our remainder. Okay? So we have a remainder of 0. So what we want to do next is we want to rewrite this as a polynomial. So we're going to go now back to a polynomial. So we started off with the 5th degree, and we took out one of the roots. Okay, because this root here represents one of these solutions. So instead of 5 solutions, now this remaining factor only has 4. So the 1 goes with the x to the 4th. Then the 2 goes with x to the 3rd. Then the 0 goes with x squared. Then the 1 goes with the x. And then the 2 is our constant. Now, we don't need this term in here because 0 times anything is 0. So if I want to continue factoring this, I would factor out a common factor, which would be like that. And then since there's nothing to factor out of these two terms, I need to factor something out because I'm trying to factor by grouping here. Grouping the first two, grouping the second two. So I'm going to factor out a 1. So if I factor out a 1, nothing changes. Okay? So now I have x cubed plus 1 and x plus 2. Now, this is the sum of two perfect cubes. X is a perfect cube because x times x times x is x cubed. 1 is a perfect cube because 1 times 1 times 1 is 1. So what we have here is, we have this is the formula that you use. I put it up on the screen for y'all. So when you have the sum of two perfect cubes, okay, you can factor that very easily. Let's see if I can get that on the screen real quick here. Let's see, there it is. Right here, the sum of two cubes. So it's going to factor to a plus b times a squared minus ab plus b squared. All right, let's go back to this. So I'm just going to put a cube on here. 1 cubed is still 1. So the a value is x. The b value is 1. The a value is x. And then a times b is going to be x times 1, which is 1x, and then the b value is 1, so plus 1. 1 squared is just 1. So this factors to this. And then we also have the x plus 2. And don't forget the x minus 2. So now we're in factored form. So let's make sure this is right. Degree 1, 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 1 is 5. This is a 5th degree polynomial, and it matches our 5th degree up here. This is standard form. This is factored form. But that's how you do synthetic division. All right, I'll see you guys in class tomorrow.